All right, I'm sorry I looked at this. I'm having a hard time now figuring out why that doesn't meet the criteria. It might have to do with the burn wound, because it isn't a sterile procedure to begin with. A sterile, anyway, I'm sorry I went down that road now because I'm recording this and I have nobody to talk to. So I will just move on to question number 8. An IP is preparing the quarterly report for the Infection Control Committee. What information will be needed to calculate a CLABSI rate for the ICU? 1, the total number of patients in the unit for the time period. 2, the total number of central line catheters for the time period. 3, the number of patients who had bloodstream infections identified. And 4, the number of device days for the time period. A is 2 and 3, B is 1 and 3, C is 1 and 2, and D is 3 and 4. So for that question I didn't know the answer to, I'm going to ask when we have a live meeting to see if anybody who's working in the hospital can explain that to me. 8, an IP is preparing the quarterly report, or we just did this one. So the answers to this are 3 and 4, which are the number of patients who had bloodstream infections identified and the number of device days for the time period. So how do you do this calculation? So Y is the denominator and the denominator is the device day. So it's how you get that is at the same time every day you count the number of patients with 1 or more central lines for the time period. And then the numerator, or X, is the event or bloodstream infection. So you have the X divided by Y times K. So what's K? K is a standardizing number. It's usually a multiple of 10. It's a whole number. And then you use this kind of a number so you can compare this result, this calculation, to other populations. So that it becomes comparable. So you use a whole number. So you divide X by Y and multiply it by 100, 1,000, or 10,000, depending on how big your number is. You want to have a number that the smallest rate calculated has 1 digit to the left of the decimal point. So there's 2 infections and device days are 15. So X is 2 and then Y is 15. So you have 2 divided by 15 and we'll say times 100 and you get 13.34 infections per 100 central line days. So if you were to multiply it by 1,000, you would have 1.3 infections per 1,000 central line days. What type of rate would the IP want to calculate to give feedback to the surgeons at her facility? A, procedure specific, B, provider specific, C, unit specific, and D, device specific. Okay, the answer to this one is provider specific. The feedback, the surgeons would want to know feedback about their own practice. The IP has been benchmarking her data to other facilities performing similar activities for a period of time. The IP should analyze the entire process to ensure that which of the following conditions are met. And you get to choose all but one of these are correct. 1, standardized definitions are used consistently. 2, overall rates are used to accurately track trends over time. 3, adequate training of personnel to collect, store, manage, and analyze data. And 4, data are calculated using the same methodology as a nationally validated system. Okay, so the answer to this one is C, 1, 3, and 4. So 2 is not correct. Overall rates are not used to accurately track trends over time. Okay, number 11, the chi-square test, or in parentheses, this is how you'll see it expressed in a research paper, X2, can be used, 1, to evaluate the effect of a variable on outcomes, 2, to analyze continuous data, 3, to calculate an odds ratio or relative risk. 4, if each cell of the table is greater than 5. So all but one of these is correct. Okay, the answer is D, 1, 3, and 4. So 2 again is not correct. So it's not used to calculate continuous data. All right, what's a chi-square test? So it tests the association between two classifications of a set of counts or frequencies. So that's discrete data. It's displayed as a 2-by-2 table in rows. One variable columns are 2-by-2 table, so that's rows and columns of 2. So there's 4 total. One variable's columns are a second variable. So you have 2 variables and you have numbers and in the columns related to each variable. So the row column totals are used to predict what count would be observed and expected if the null hypothesis were true. It's used for medium to large samples, okay? That's important. The other test that you would use on discrete data, if you had a sample size that's less than 20 or any one cell in the whole table is less than 5, is called the Fisher's exact test, okay? So this chi-square test is for medium to large samples. This is something that would be calculated by a statistics program, and you can also do it in Excel. The measure of central tendency most affected by outliers is A, mean, B, median, C, mode, and D, range. Okay, so the answer to this question is A, the mean. So the measures of central tendency are all the 4 options for those answers. Mean, median, mode, and range. So the mean is the average. And because the mean includes the value of every number in the data set and that number counts equally, it can be pulled toward extreme outliers, especially in a small data set. So you can imagine if you have a bunch of numbers that are 1 through 10, and then you have 100, that's going to pull your data. So it seems like the average person or the average number is higher than, it pulls the average higher, but doesn't really reflect the numbers in the data set, the middle, or the average person. I'm thinking about grades here. So if you have grades and everybody gets less than 50 except one person gets 100, and you average all those out, it's going to pull that number higher than the 50, which was what most people got. The median is the middle of the data set, which is less affected by outliers because it just will pull the middle number. So if you, again, in the same example, if you have numbers 1 through 50 and then somebody else gets 100 on the test, the 50 or 49, whatever the middle number is going to be, and it's going to be less than 50 probably. So it shows that most of the people that you're looking at in the population who got those grades scored lower. And then the mode is just the most frequently occurring number in the data set. Not every data set has a mode. Some have 2 modes, and we'll talk about that as we go along. And then the range is the difference between the highest number and the lowest number in your data set. 13, the p-value in a statistical result indicates causation, and these should have letters beside them. A, causation. B, the probability of committing a type 1 error. C, the probability of committing a type 2 error, and D, the probability of the data being accurate and valid. Okay, so the answer to this one is B, the probability of committing a type 1 error. So what is a type 1 error again? It's when you reject the null hypothesis. So the null hypothesis means there's no difference, okay? In either data set. So you turn away, your result is showing there is in fact a difference when there isn't one. So it's a false positive. The p-value is the calculated probability of rejecting the null hypothesis when it's true. So it's usually 0.05, okay? So when you're looking at a p-value, it's telling you that fairly certain that this result is accurate, but there's a 0.05 chance that it's not. On a normally distributed data set, what percentage of the values lies within 3 standard deviations from the mean? A, 68.2, B, 95.5, C, 92.4, and D, 99.7. Okay, the answer is D, and we're going to look at that chart again. So the 99.7% of the values in a normally distributed data set lie within 3 standard deviations from the mean. So again, here's that picture. So 1 standard deviation, a data point 68.26% of the data points will lie between 1 standard deviation, and 2 standard deviations, so 95.46% of the data will lie between 2 standard deviations of the mean in a normally distributed data set. And as the answer to this question indicates, 99.73% of the data points in a normally distributed data set will lie within 3 standard deviations of the mean. Which statistical test is used when the data are small in numbers? A, Fisher's exact test, B, t-test, C, chi-square test, and D, z-test. These are all real tests. Okay, the answer to this one is A, the Fisher's exact test, and we talked a little bit about that a few minutes ago, or I talked a little bit about it when we were talking about the chi-square test. So both the chi-square test and the Fisher's exact test are tests used on discrete data, and the Fisher's exact test is when the data set is smaller in numbers, and chi-square test can be used on medium to large sample sizes. 16, statistical process control charts are used for all of the following purposes except A, to monitor the process of care, B, facilitate the determination of variation, C, eliminate natural variation, and D, monitor outcome. Okay, it is statistical process charts are used for everything on this list except to eliminate natural variation. Had no idea what those were when I was studying for this test originally. So what is a statistical process control chart? It's a method of quality control. It's used to monitor both processes and outcomes in a systematic and statistically valid manner. Control charts can exist and help you determine the causes of common cause variations, which may help early identification of abnormal events. So if you're watching, like, for example, if you're watching your hand hygiene, compliance, and also outcomes like infections, when your compliance may go low, you can chart all that out. You can use this for looking at antimicrobial stewardship. I don't know if you can use this for that, but you could watch your antibiotic prescriptions and also maybe an outcome like C. diff infection on the same chart. 75 patients were admitted to the medical surgical ICU. 40 were on the surgical service and 35 were on the medical service. 15 patients developed a healthcare-associated infection with MRSA. 9 of the patients with MRSA infection were on the surgical service. There were 200